Have you ever stopped and wondered why AI models are getting so unbelievably huge? We're talking models that cost millions of dollars and use up terrifying amounts of energy to train. It just seems kind of backwards, right? Well, today we're going to dive into this wild idea that maybe we're not just building bigger castles, we're actually just buying a giant roll of lottery tickets, hoping to find that one single winning key. Right, let's just get straight to it. This whole race for smarter AI has led to a total explosion in model size. We're talking networks with hundreds of billions, sometimes even trillions of parameters. And this scale is a real puzzle because for the longest time, all the experts said this was exactly the wrong way to do things.
Yeah, for agents, the golden rule in machine learning was simple. Don't make your model too complex. It would just lead to this thing called overfitting. Basically, the model gets really good at memorizing its homework, but then completely fails the final exam on stuff it's never seen. But recent discoveries have pretty much flipped that whole idea on its head. The new thinking is that these giant networks aren't just bigger, they contain so many possible pathways that they're almost guaranteed to have a secret, super efficient little network hiding somewhere inside.
And that, right there, brings us to the main event for today, this idea of a winning ticket. It's the core concept behind a really groundbreaking theory called the lottery ticket hypothesis. Okay, so let's break down that formal definition because it's a mouthful. What it's saying is that inside any huge, randomly started neural network, there's a tiny, sparse subnetwork hiding out. And here's the crazy part. If you could just find that little network and train only it from the very start, it would perform just as well as the entire gigantic model. It's like finding a secret, pre-wired brain that was just perfectly set up for the task from day one. And this quote from the original researchers, Jonathan Frankel and Michael Carvin, just nails it. They put it perfectly. It's not just about finding a smaller structure. It's about the fact that this little network had the perfect random starting values from the get-go. It literally won a lottery the second it was created. So you're probably thinking, if these winning tickets are so amazing, how on earth do you find one? Well, the process is surprisingly simple, and that's what makes this whole idea so cool. Let's just walk through the 3 steps. All right, here's the recipe. First, you train the whole giant network like you normally would. No surprises there. Second, you prune it. That just means you look at all the connections and you chop away a huge chunk of them, specifically the ones with the smallest values, the ones that seem least important. But now comes the totally mind-bending part. Step 3, you don't keep the weights you just trained. Nope. You take that new skinny skeleton of a network and you hit rewind, taking its weights all the way back to the random values they had at the very beginning. And the result of this, it's absolutely astonishing. The winning tickets you uncover are often less than 10 or 20% of the original network size. I mean, that's an 80 to 90% reduction. We're talking about a massive drop in size and complexity, and it still performs just as well. It's wild. So this really gets us to the heart of it all. The secret sauce, the magic ingredient, isn't just finding a smaller network. It's that lucky initial combination of weights that the structure had from the very beginning. To really put this to the test, the researchers asked a really simple but brilliant question. What happens if you find that perfect winning structure, but instead of rewinding its weights, you just give it a new set of random weights? And the results of that experiment tells the whole story. Just look at this table. In the top row, you've got the real winning ticket, trained with its original lucky starting weights. It learns faster and can actually get better results than the full bloated network. But now check out the bottom row. You take that exact same structure, but you give it a fresh set of random weights, and the magic is just gone. It learns way slower, and it can't even get close to the original network's accuracy. The performance just tanks. So what this proves is that it's a 2-part secret. You absolutely need both the right map, that's the sparse network structure, and the perfect starting location on that map, which are those original lucky weights. You can't have one without the other. It just doesn't work. Now, this whole lottery ticket idea doesn't just exist on its own. It actually helps explain another really bizarre thing that's been happening, something that's forced us to rewrite the entire rulebook for AI. For decades, everyone in machine learning knew this U-shaped curve. It was gospel. As you make a model more complicated, its error rate goes down, it hits a perfect sweet spot, and then it starts to go back up again as it overfits. That was the law. End of story. But then, with the truly massive models we have today, something weird started happening. Researchers found that if you just keep making the model bigger and bigger, way past that point where it's supposed to be overfitting horribly, the error rate, well, it starts to go down again. This is called the double descent phenomenon, and honestly, it baffled everybody. And guess what? The lottery ticket hypothesis gives us this beautiful, elegant explanation. Why do these massive, over-parameterized models suddenly start getting better again? Well, it's because making them so enormous is like buying more and more lottery tickets. You're just dramatically increasing the odds that a winning ticket subnetwork was in there from the very beginning, and the training process is just getting better at finding it. Okay, so this is way more than just a neat theory for academics. Understanding this whole lottery thing has some really profound implications for how we're going to build the next generation of AI.
I mean, the possibilities here are huge. First off, just think about the efficiency. Imagine if we could find these winning tickets before we even start training. We could save incredible amounts of time, energy, and money. Second, we could design better networks. By studying the structure of these winning tickets, we could learn what an efficient network actually looks like and just build them that way from the start. And finally, it just gives us a deeper understanding, forcing us to rethink how these incredibly complex systems learn in the first place.
Really, what this does is it completely shifts our perspective. Building powerful AI might be less about the brute force art of just stacking more and more layers, and more about the science of finding or even engineering the perfect starting conditions, the right initial structure, and the right initial weights. And that leaves us with this really tantalizing vision for the future, right? Maybe the key to truly powerful AI isn't in building ever larger digital brains, but in getting really, really good at finding these perfect, tiny, efficient subnetworks that are already hidden inside. So the big question becomes, could the next great leap forward in AI come not from building bigger, but from getting much, much better at finding these winning lottery tickets?